Hello, so I'll be doing my homework question example video on 15.5. So, homework 15.5. So, part A says an athlete exerts a tension of 6.00 times 10 to the power 2 newtons. So 600 newtons on one end of a horizontal rope that has 50 meters and mass 2.50 kilograms. Rope. 50 meters and 2.50 kilograms. Now the other end is tied to a post. If she wiggles the rope with the period 0.575 seconds and amplitude 3 centimeters, what is the angular frequency of the oscillation? Wiggles rope with period of 0.575 seconds and amplitude 3 centimeters. What is the frequency of oscillation? Okay, so what I'm given in this problem is I'm given the tension, 600 newtons. I'm given horizontal rope length, so rope length of 50 meters, and a rope mass of 2.50 kilograms. I'm given the period of 0.575 seconds, and then amplitude of 3 centimeters. And it's asking me to find the angular frequency. So I know to find angular frequency, we're going to need 2 pi, and I'm dividing that by the period. And since I'm given the period already, this turns to 2 pi over 0.575 seconds. And if I put this in the calculator, I'm going to get 10.89 radians per second. Okay, so for part B, this one says, what is the average rate at which energy is transferred along the rope? So to solve for average rate of which energy is transferred along the rope, it's asking for power. And I know that the formula for power is equal to 1/2 of the linear density multiplied by the angular frequency squared multiplied by the amplitude squared, and then that's multiplied by the wave speed. So what I'm given in this problem is from up here. So all of these values right here. Okay, so I'm given everything right here. And I just solved for the angular frequency. So I'm just going to write as 10.9. So what I need from this problem is, if I plug in my known variables right now, I get I still need to find the linear density, and then I have the 10.9. Then I have my amplitude, which is 3, and then I need my wave speed as well. So I need to find my wave speed, and I know how to find wave speed because that is the square root of the tension force divided by the linear density. To find linear density, I know that's going to be the mass divided by the length. So that'll be, mass divided by length, which is 2.50 divided by 50. If I put this in my calculator, 2.50 divided by 50, I get 0.05. Now to put that into my wave speed equation, I have my tension, which is 600, and I divide that by 0.05. I get 600 divided by 0.05. 100 and I'm just say 110. Round that up, meters per second. So now that I have all my variables here, I'm able to plug that in. So I have 1/2, bring this down here. So 1/2 times the linear density, which is, we found 0.05, times 10.9, times 3, times the wave speed, which is 110 meters per second. And this is equal to the average rate. So I'm just average, which is also power. So put this in my calculator, 1/2 times 0.05 times 10.9 times 3 times 110. No, wait, I forgot that this is squared. So this is my angular frequency is squared, and so is my amplitude. This is squared and this is squared. And then this is, I have to convert it back. To convert this into meters, 0.03. meters. And this is 110. This is all squared. Okay, everything looks good. I have to rewrite this. So 1/2 times 0.05 times 10.9 squared times 0.03 squared times 110. Okay, and then I end up with an answer of 0.294, and this is gonna be work. That's my unit right there for power. Okay. Part C. This one says length of piano wire. Length of piano wire. This one says the mass density is equal to 5.55 times 10 to the power negative 4 kg over m. It's under 185 newtons of pressure. Oh, tension. Whoops. Tension. A sinusoidal wave of frequency 256 hertz carries a maximum power of 5.2. Work along the wire. I don't know why I'm saying work, it's watts. So, sinusoidal wave of frequency 256 hertz carries max power of 5.20 watts along wire. What is amplitude of this wave? Okay, so it's asking for the amplitude of this wave. So I'm going to be using this power formula. You know, the linear density multiplied by the angular frequency squared times the amplitude squared. And since I'm finding my amplitude, I'm going to rewrite this as A is equal to square root of P over linear density times angular frequency squared. And what I'm given is, the linear density, 5.55 times 10 to the power negative 4 kg over m, and the tension, 185 newtons, and the frequency, which is 256 hertz. Then power I'm given is 5.20 watts. So I have everything necessary. Well, I need the angular frequency first. And the angular frequency can be used as 2 pi times the frequency. So 2 pi times 256. Put that at my calculator. I get angular frequency is 1608.5. Radians per second. Now I can use this, plug it in. So A is equal to square root of my power, which is 5.20 watts, divided by linear density, which is 1608.5, multiplied by the angular frequency. Oh yeah, this is my angular frequency, and I multiply by the linear density, which is 5.55 times 10 to the negative 4. So putting this in my calculator, 5.20 divided by 1608.5, that's going to be squared times 5.55 times 10 to the power of negative 4. I need to put this again in my calculator. Messed it up. I forgot my velocity. But what is the amplitude? Did I forget my... Yeah, I did. The speed of the wave speed. Forgot to add that to my formula. So I know to find this, it would be tension divided by the linear density. So tension is 185, well, square root of 185 divided by the linear density, which is 5.55 times 10 to the negative 4. So that'll be 185 divided by 5.55. Wait, 185 divided by 5.55 times 10 to the power of negative 4. Here's a wave speed, 577.35. Okay. 577.35. Now I add this 577.35. So I get an answer of 0.0025 meters, but I have to convert this back into millimeters, so I have to multiply it by 3. Yeah. So times, multiply by 1,000, so 2.5 millimeters is my answer. Okay, part D. Portable audio speaker. Portable audio speaker. Has a power output of 8 watts. I'm gonna move this down. Okay. 8 watts. If the speaker emits sound equally in all directions, what's its sound intensity? What is the sound intensity at 2 meters if sound is equally emitted all directions? Okay, so this problem is looking for sound intensity. So I know sound intensity is used to find as the power gets divided by the amplitude. And in this question, I'm given the power, which is 8 watts, distance, which is 2 meters, and this will actually be my radius since it's emitted in all directions. All directions. So I need to find my A, and I know A is represented as amplitude is equal to 4 pi times r squared. Given I have r, just 4 pi times 2 squared. So using my calculator, 4 times pi times 2 squared. And I'm given that A is equal to 50.27. So this is meters. Now I just plug it to find my sound intensity. So power, which is 8, divided by 50.27. Put this on my calculator and I get 0.159 watts per meter cubed. Squared. Meter cubed. Meter squared. Jeez. Watts divided by meter squared. Okay. Next question. I'm gonna add a page here. We were just on part D, right? A, B, C, D, E. Part E. Part E says, what distance from the speaker is the intensity equal to 0.045 watts per meter squared? So now it's asking me to find R, because I'm given, I, 0.045 watt per meter squared. And now I was given power, same problem, 8 watts. Now I'm looking for R. So in this problem, in the previous problem, I knew I is equal to P divided by the amplitude. And in this problem, I don't know the amplitude, so I can describe it as 4 pi r squared. And since I'm solving for R, I can rearrange this formula to look like R is equal to, move square root P divided by 4 pi I. I'm gonna change my color. So plugging in my known values, I have R is equal to square root of 8 watts divided by 4 pi, and then the intensity of sound is 0.045, right? And now I just solve for R. So using my calculator, square root of 8 divided by 4 times pi. 4 times pi times 0.045. And I end up getting an answer of 3.76. And this will be in meters. Okay. Alright. A, B, C, D, E, F. Part F. So it says the ears of a frog are 2 circular membranes located behind the frog's eyes. In one species of frog, each membrane is 0.5 centimeters in radius. So each membrane is 0.5 centimeters in radius. If a source of sound has a power output of 2.50 times 10 to the power of -6 watts, so power is equal to 2.50 times 10 to -6 watts in all directions. And is located 1.5 meters from frog. 1.5 meters from frog. How much sound energy? How much sound energy arrives at one of the membranes? Each second. Okay. So I am looking for how much sound energy. So I'm looking for energy. So I have to find. It looks like I'm looking for power. So what I'm given is I'm given radius 0.5 centimeters. Power is equal to 2.50 times 10 to the power of -6 watts. And located 1.5 meters from frog. Okay. Okay. So I need to find the sound intensity first. I don't have amplitude, so I'm gonna rewrite this as P4 pi and R. I'm not. Located 1.5 meters from frog. So I'm gonna use 5 centimeters. This is my first radius and my second radius. Distance, no. The distance from the frog is 1.5 meters. So I'm going to, and I'm given power, so I'm going to calculate this. So 2.50 times 10 power of 6 divided by 4 pi times 0.5 centimeters. let me read this again. My radius is not 0.5. Okay, so it says so my distance is equal to 1.50, and then in the one membrane it's 0.5. So the radius of the membrane 0.5. So I'm solving for the sound intensity. So I'm using the distance, so it should be 1.5. So I put this in my calculator. 2.50 times 10 to the power of negative 6 divided by 4 pi times 1.5. And I get 1.33 times 10 to the power of negative 7. So this will equal my sound intensity, which would be 1 per meter squared. Now, using my intensity, well, I still have to find the area of the membrane. So to find area of one membrane, I just use my regular pi r squared formula. And since I'm using the membrane radius, I'll be using pi r and then 0.5 squared. So pi times 0.5 squared is equal to 0.785 meters. Okay. Now after that, I'm going to plug it into my power equation to find the energy of the sound energy. 1.33 times 10 to the power of negative 7 multiplied by amplitude, which is 0.785. So multiply these together. Wait. This is squared. R squared is squared. This is why. Yeah, it looked too small. I mean, it was too big. So for this answer, I should get 2.50 times 10 to the power of negative 6. 4 times pi times 1.5 squared. Okay, so I get 8.84 times 10 to the power of negative 8. And then I get this number, (8.84 times 10 to the power of negative 8. Multiply that by 0.785. Okay, this number looks better. Okay, so my sound energy is equal to 6.94 times 10 to the power of negative 12. Yes. And then I have to convert this into, because this was in centimeters, So I have to convert this into meters. So 0.00075. Yeah. I get negative 12. And then this is in joules, it's sound energy. Okay, and that's it.